guys. Hope you had a great day yesterday. These are your notes for yesterday and today, and then we'll review these tomorrow. So today we're going to start with a little review of all the functions we've learned, okay? What makes a function a function? All together now, x value does not repeat, okay? Keep that in mind. All right, so first set of functions we learned about were linear. Standard form of a linear equation is ax plus by equals c. Standard form of a quadratic we've learned about is ax squared plus bx plus c. And today we're going to add the y equals or the f of x equals. So now we're turning it into a graph. Okay, guys? So ax squared plus bx plus c is what we've been doing to factor and to multiply and all those other good things we've done the last two chapters. Now we're going to be turning it into a graph, okay? This is standard form of a quadratic function. So we need to always make sure our equations look like this so we can determine the size, shape, location of a quadratic function, of the graph of a quadratic function. What is the graph of a quadratic function called? I'm glad you asked. It's called a parabola. Okay, guys? Anyone remember what the graph of a linear function is called? A line. Okay? So we talked about functions, then we dealt with linear functions for a while. Now we've been dealing with quadratic functions for a while. Now we're going to start to graph them. So the graph of a quadratic function is a parabola. So there are a number of things we need to determine before we graph a parabola. Okay, so I'm going to make a list of everything we need to determine and how we do it, and then we'll do a couple of examples, okay? So I'm going to erase this, and we're going to put the list of things we need to do over here. So the first thing we need to do is we need to determine, does our parabola open upward or downward? Okay, so make sure you have that down. Okay, that's the first thing. Second thing is, what is the x-axis of symmetry? The third thing is, what is the vertex? How do we find it? So we're going to find, how are we finding this will come up next. What is the vertex? Then the next thing we're going to look for are our x-intercepts. The next thing we're going to look for is our y-intercept. The next thing we're going to look for is our domain and range. And then the last thing we do is a table of values and graph. Okay. So there's a lot of stuff that goes into one of these problems. Okay? I'm going to give you guys a couple seconds to finish writing that down. I'm going to take a drink of my coffee. It's early. Okay. If you have some questions already, jot them down on the side of your paper so you can remember tomorrow, but most of them are going to be answered by the time we get done with this, okay? All right. So let me leave that right there. Let's start answering some of these questions. So now in your notes, if you've written the questions down in a row, now you can start putting some formulas down next to it. All right, so what I'm going to do is I'm going to put number 1. That means, does our parabola open upward or downward? Okay, there's a way you can see this very simply. Okay, so remember our standard form, y equals ax squared plus bx plus c. Okay, to determine if the parabola opens upward or downward, we look at A. We're gonna look at A. If A is greater than 0, it goes up. The graph goes upward. If A is less than 0, it goes downward. A can never, ever, 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 ever be 0 because it's not a function then, okay? So if A is greater than 0, it goes upward. If A is less than 0, it goes downward, okay? That's the answer to the first question. So if we have negative 4x squared plus 6x plus 4, A is negative, so it's less than 0, so the graph would go downward. The shape of a parabola is like a waterfall. The water shooting out of a fountain. There you go. That's what a parabola looks like. So if you're at Buckingham Fountain, that's what your parabola looks like. It's all the water coming out of the fountain. A parabola can never, ever, ever look like this. Why, do you ask? Well, you tell me. Here's my x-axis, here's my y-axis. Why can this graph not be a function? Because our x values repeat, okay? So a parabola can only go this way or this way. Okay, guys? So make sure you draw a little sketch like that too. Okay? So in this particular equation, negative 4, so A is less than 0, it would go downward. Okay? Number 2, what is the x-axis of symmetry? This is where it gets interesting and fun. Any of you ever learn the song Pop Goes the Weasel when you were little? Did your parents sing it to you? Well, Evan's frowning back there because it's torture when math teachers teach this, but so it's a little song that will always help you remember the formula for finding the x-axis of symmetry. All around a mulberry bush, the monkey chased the weasel, da 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 da, pop goes the weasel. So your formula for x-axis of symmetry is x equals negative b all over 2a. Sing along with me now. X equals negative b all over 2a. You need to memorize that. Okay, so that is how you find your x-axis of symmetry. So you're going to take the opposite of b, which here would be negative 6, because whatever b is, you're going to take the opposite. So instead of a positive 6, it would be a negative 6. And then over here you do 2 times a, which is negative 4. Okay, negative 6 divided by negative 8 is 6/8, which simplifies to 3/4. Okay, I should have come up with a whole number. We're going to graph one next time. I just wanted to see how you could input numbers for a formula. Okay, so x equals negative b all over 2a gives you your x value. So then your next question is, what is the vertex? So whatever we get for our x-axis of symmetry is our x value, 3/4 comma. So you're going to input 3/4 wherever you see an x. So y equals negative 4 times 3/4, okay, squared, plus 6 times 3/4 plus 4. When you figure all of that out, that would be your y value, which would go in here. That's your vertex, okay? We'll get to graphing in a few minutes, okay? Just want to show you what we're doing here. So you have to go in this order, all right? This is the order you must solve every parabola, okay? So the next step, what are my x-intercepts? Usually you have to determine that after you've graphed it, okay? So we're going to skip that one for right now until we get to a graph. All right, y-intercept. So in a linear function, if we had y equals mx plus b, so let's say y equals 4x plus 4. Remember doing those, guys? What's the first thing we graph? Our y-intercept. How do you find the y-intercept? It's over there. So what do you think my y-intercept is in a quadratic function? You got it, C. Okay? Y-intercept equals C. Same thing. But we don't graph it first in these, okay? All right, domain and range. Actually, y-intercept should come down here. That's 5. X-intercept will come back to, okay? All right, 6 is domain and range. Domain is going to be all real numbers. Remember when we did these back at the beginning of the year? Domain is always going to be all real numbers. So you can write it. Remember how I showed you the handy dandy shortcut? Or you can put all real numbers. Okay? The range is going to be whatever the top of your graph is, or the bottom of your graph, and going forward. So we're going to get to the range and the x-intercepts here in just a minute, okay? The last thing I want to talk to you about is if your vertex is going to be a minimum value or a maximum value, okay? So once you get your vertex, you're going to be able to determine if it's a minimum value or a maximum value. How, do you ask? Well, by going through this. So once you get your vertex, okay, and you have your first point, if it's greater than 0, your graph's going to go up, right? So that would make your vertex a minimum value, because everything is going to be greater than it. If A is less than 0, it means your vertex is going to be your greatest amount, so it's going to be a maximum value, okay? And we'll get to that in just a minute too. Okay, so let's do a graph and see. I want to show you some of these things. So now we've written down all the information. Now I want to show you this. All right, so let me take a smaller graph here. This is why I told you guys you might want to get some graph paper. All right, so here's a graph of a parabola. Let's see here. Let's do an easy one. So we're going to do y equals negative 2x squared plus 2x minus 3. Actually, this one's really not an easy one. I want to do a really simple one for you guys first. So, erase that. Sorry, guys. Let's do f of x, or y, equals negative x squared, this is better, minus 4x minus 5. Okay. So let's do this. So does our parabola open upward or downward? Well, A is a negative 1, so it is the smallest value, so it is going to do what? It's going to open upward, okay? Downward. It's negative, it's open downward, guys. I'm sorry, I need more coffee, okay? So we know it's going to open downward, which is going to make our vertex the maximum value. So those two go hand in hand. Negative value goes downward, means your vertex is a maximum, okay? So you'll see that in just a second. So let's find our axis of symmetry. X equals negative b over 2a. So what is our opposite of b? So it's negative 4, so the opposite would be 4. 2 times a is negative 1, so negative 2. So what does x equal? Negative 2. Okay, let's find y. So now wherever we see an x, we're going to put in negative 2. So y equals the opposite of negative 2 squared, minus 4 times negative 2 minus 5. 4, opposite of 4, so negative 4 plus 8 is 4, minus 5 is negative 1. Okay, guys? All right, so now we have our vertex, correct? Yes. Okay. I'm giving you guys a second to write that down. So our vertex is negative 2 comma negative 1. All right, so that's the first thing we graph. So we come over here, negative 2, negative 2 comma negative 1. So that is our vertex. We know it's a maximum value because it's less than 0, so we know our graph's going to go this way, okay? What's our y-intercept going to be? Negative 5, right? So 1, 2, 3, 4, 5. We know it goes there. Okay, so that's where we know it's going to cross the y-intercept. The x-intercepts, it's actually not going to cross the x-intercepts, right? Because this is a maximum value. It's going to go down this way, so we're not going to have x-intercepts. That's why sometimes I think it's easier to just wait until you've graphed to see what your x-intercepts are. All right, so this one is not going to have x-intercepts, so you can say none. All right, what is the domain? Domain's going to be all real numbers. What is the range? I'm glad you asked. So what is the value of this parabola going to be? So we go down negative 1, right? Range is always done off of our y-axis, okay? So our range is going to be anything less than or equal to negative 1. So remember how we wrote that? Y of y is less than or equal to negative 1. Okay, that's our range. Okay, so that's everything we just did in an example. All right, sometimes I'm going to give you a graph and you're going to determine these things from the graph. So you're not going to have to mathematically figure it out, you're going to have to visually figure it out. So let's do one like that too. All right, so let's do one like that. And then I'll give you some ideas of what to look for so you can see what your graph's going to look like. All right, how do I want to draw this one? Okay, so we have a parabola that looks like this. I don't know, Evan, if you can zoom in a little bit on here. So we already had those. Okay, and then we have negative 1, negative 2. Okay, so we're not looking for an equation here. All I'm looking for is answering the question. So does our parabola open upward or downward? Upward, which would make our vertex what kind of value? The minimum, okay? because everything else is greater than the vertex, right? Good. So does that mean A is negative or positive? I'm hoping all of you are saying positive, right? Good. Okay, so what's the x-axis of symmetry? So that means the x-axis of symmetry, so now it's visual, so I want you guys to see it visually. X-axis of symmetry divides your parabola evenly, straight through the middle of it. So it's going to be one value. X equals your x-axis of symmetry. So what is our x-axis of symmetry? 1. X equals 1. Okay, that's how you write it. Your vertex would be written as an ordered pair, x comma y. So what is our vertex? 1 comma negative 1. Okay, so you would write that there, 1 comma negative 1. Okay, what are our x-intercepts? So now you can see them, right? Where does it cross our x-intercept? So where does it cross our x-intercept? It crosses at 0 and 2. Perfect. Okay. Then we want to know our y-intercept. So where does it cross the y-intercept? At our origin, right? Y equals 0. Okay. And then our domain and range. Domain is all real numbers, everybody now. And our range would be any number greater than negative 1. So y of y is greater than or equal to negative 1. Okay, you always have to have the greater than or equal to because it can include that point, okay? And we already have our table. We already have our graph. We won't get to the table until probably when we review tomorrow. Okay, how's everyone doing with this? Not so bad? Okay, should we try one more? You know what? I'm going to explain how we do our table of values and then we'll graph one together tomorrow. Okay, so the way we do our table of values is this. You find your vertex, okay? And you find your x-axis of symmetry. So let me write this out. And this is the last thing I think we're going to do today. Then we'll graph one tomorrow from start to finish with a table of values together. Okay, so once we have our x-axis of symmetry, that determines our vertex, right? We input for x to get y. So you can make your table of values from that. X, and then you'll put your equation, substituting in for x to determine y. Okay, this is how it will look tomorrow. So your x-axis of symmetry is going to be your middle value. Then you can pick any value greater than or less than. So your less than values would go up here, and I'm going to ask for 5 points, just like I did for lines, right? Minimum of 3. We're going to start out with 5, okay? And then you guys can work towards 3. You usually need more than 3 points to get a good idea of what it looks like. X-axis of symmetry goes in the middle, and then you have 2 values greater. So 2 values that are less than, and 2 values that are greater than. Why do you think we do that? Because the x-axis goes straight down the middle, so we want to see how equidistant it is on the right and how it looks on the left. They're going to be equidistant from each other, okay? So that's one thing we're going to look for when we start graphing these. Are they the same distance away from each other? Otherwise, we made a computation error. Now, there's another way to kind of determine how a graph looks. That's your value of A. The larger A is, the more narrow the graph is. The smaller a is, the wider the graph is. Okay, so a is going to determine the width. C determines where it crosses your y-intercept, and B gives you an idea of the location. Okay, I think that's all I have for you today. So I've gone through all of my notes. Evan, did I miss something?
I don't think so.
Nope, I don't either. So guys, this is everything. I told you there was a lot. So I talked for about 30 minutes straight. So I appreciate you listening. If you'd like, go through this again so you can jot down a few more notes with it of things you're picking up now. And then tomorrow we will go through this together. So if you have graph paper, great, bring it. It'll make your notes a little easier to understand. If not, I will try and get a picture of some of mine and email it to you, okay? But if your parents are out and about, I know it's hard to get into a store right now, so I get it. So I'm gonna try and take a picture of it and you can print some off at your house, okay? I'm actually gonna make myself a note right now, email graph paper, okay? And I will see you guys tomorrow. Bye.